Good afternoon and welcome. At GSD Idea webinar, we will be discussing topic of all connections in one go and workflows in Idea Statica Checkbot. So I hope everybody's safe in these very turbulent times in the Middle East. Hopefully, we will take this seminar as an opportunity to get our minds to some nice topics. Okay, so I would like to welcome you. My name is Jan Barta. I'm a managing director at GSD Idea, and together with Rose and Venkatesh, we will be spending the next hour together, and again going through the example projects of roughly 200 connections and the way how we can manage to do it up until the delivery with the latest tools. Rose, how are you today?
Hello, Jan. I'm good. How are you? And hello, everyone.
Good, thank you. And we have Venki, as mentioned. Venki, are you with us?
Hello, Jan. Hope you're doing good. I'm fine as well.
Wonderful, wonderful. Thank you. So my colleagues will be joining us on stage later. Today, we're launching the webinar on a completely new webinar platform called Demio. In order to ask questions, use chat tab on the right-hand corner of the UI. We would be launching 2 polls today, so you can respond to those. We would be very happy if you respond in the poll section next to the chat tab. As usual, we'll be responding to the questions on the go. If we will not be able to respond to that particular question, we will follow up via email. You can expect the Q&A section at the end in case there'll be some resonating topic. So that'll be coming at the very last. Before myself, I'll be doing a very quick overview of how Idea Statica helps structural engineers in 2025. And then I will hand over to Rose and Venki to actually focus on the Checkbot BIM workflow and the particular details of the whole process. So without further ado, how Idea Statica helps structural engineers in 2025. Everybody knows Idea Statica for the complex connections. No need to further introduce this use case. Everyday connections is another one, those that you typically process in your Excel spreadsheets, simplistic tools like Cram Connections, Limcon, Procon. All these can be handled by Idea Statica very fast. Anchoring, very resonating topic, as it takes a lot of time to get it, to process it, to get it out of the table, especially when you need to code check the reinforcement in concrete block. Concrete discontinuities, specific topic for concrete projects. Whenever you have opening, hunch, pier cap, pile cap, all those discontinuity regions. Stability issues of a member, not the global ones, the local ones. And BIM workflows. So if Idea Statica applied on all of these, customers can expect saving in roughly 23% of time on the whole project. And it'll be very interesting to see the presentation today, because we will actually show you how you can look into those savings. And actually, on some projects, this saving can be even higher. In any case, if you're searching into material saving, you can have it as well in case you're a fabricator, or if you just want to optimize the topology, the geometry of your project, it can be done in Idea Statica as well. Average saving around 88%. And with Idea Statica, you're always on the safe side. Today, we'll be focusing on 4 of these 6 use cases. So today we will be looking into how to process complex connections, everyday connections, and anchoring on the example project of a steel hall. And all this will be wrapped into BIM workflow. So this is the topic of today's webinar, and I'm happy to hand over to Rose, who will introduce the further details to you. So Rose, please take the presenter and take it away.
Thank you so much for the wonderful presentation, for the wonderful introduction, Jan. I'm just sharing my screen. Please confirm that you can see my screen.
Yes, it's visible. Go ahead. Thank you, Rose.
Thank you. So, starting with all connections in just one go. Now, before I start with the complete explanation of it, I would like you to just know about the workflow, the overview of the entire design process that we are going to see in a short while. So the first one, as we all know, that is an analysis. We do the global analysis in the FEA software for the members, and then be it Stat Pro, ETAPS, ETAP, SAP 2000, TSD, etc. And then we take the connections, or we import the connections to Idea Statica connection application via checkboard. So in the checkboard, we import the entire geometry to the checkboard, one thing. And the second is that we use the load combinations from our source application, source FEA application. And then moving on to our next procedure, which is the connection design. We design and optimize the connection for the real loads. And with the 25.0 update, the checkboard new update, we can design the connections by grouping them. Now, this is what we are going to see in today's session. And now, once the design is done, all we have to do is to just do the deliverables, which is the report and the drawings, the detailed calculation and bill of materials of the entire connections can be generated within the checkboard. And also we can import the entire connections to IFC and 3D drawings. Now let's see the example that we are going to see today, which is this is the this is a frame that I'm taking today. And there are 200 connections in this, and let's see how exactly checkboard could simplify the design procedure for 200 connections in here. But before that, I have a question for all the structural engineers with us today. That how much engineering hours would it take to you to analyze, design, code check such a structure? So you can definitely cast your votes as answers. So as Jan has already directed, you can go to the right hand side of your session, and then there's a chat. Next to that, there's polls. Please cast your votes under there. I can see that more than 24 hours, less than 6 hours. Okay, 6 to 12. I'll give it a bit more time. And yes, I think the vote is stable now. So 19% of you has voted less than 6 hours, 33% for 6 to 12 hours, 23% for 12 to 24 hours, 27% for more than 24 hours, which is quite surprising. And at the same time, there is a news for all of you who have voted more than 6 to 12 hours, anything more than 6 hours. Idea Statica, we can do it in 2.5 hours. And let's see how exactly we can do it. I'm starting with a video. And we are considering STAD FEA software in here, and this is the post-processed model wherein I have already established the plugin in the STAD so that the connection import would be a smoother process for us. The plugin establishment can be done either on the desktop application on or manually. Now we are bringing in the connection in just one click, and you can see that both the geometry and the members, along with the loads, are imported to the IDEA Statica checkboard. The UI that you see right now is a checkboard application. And you might have already noticed that there are arrangements in groups. So, along with the members, geometry, the loads, we do have the grouping as well. Now, let's see in deep what exactly the grouping mean in checkboard, how we can group them in checkboard. Now, moving on in here, before we see the individual groups, I'm going to take the complete connection. Let's see what we have brought into the checkboard. So in here, I can see that there are 118 connections, which are all undesigned, which is why the to be designed option still remains as 118. It is 100% is to be designed. And then as you progress with the design process, you'll be able to see the change in the percentages of the understated um, parameters. And so just to elaborate here, we have brought in 118 connections. So those are all the different joints that we brought in. And within that one single joint, we could have multiple connections. Say we are looking at this more complex node. We have beam to beam connections here, beam to column connections here, bracing connections, and all within that one single node. So that's what we mean by a connection. And that's basically a node. Here you have the status of your entire project. So we have 118 connections to be designed. Since this is a under designed project, all of them are set to be designed. And as we keep going, we could also see the groups, which is group 1, and each joins are highlighted by groups. And if we start to explain the group, you can see that there is group 1, and 374 is highlighted as the reference connection with an underline on this. And you can also see that we have the color highlights as well. If you press on group 1, you'll be able to see what exactly is the or where exactly is the group, which is highlighted in yellow color. Along with that, the selected connection, which is 374, is in orange color coding as well. And if we deeply look on that member 374, we have the name, the node, the connected members, and all the details related to that particular connection. And furthermore, we can also see that how is the grouping done. Visually, we can see that how is the grouping done. Now, to speak more on the groups, that how exactly the typology of the grouping which happened in checkboard, we can see in detail here, wherein if you press on group 1, we'll be able to see the name of the group, which is editable. You're welcome to edit it at any point of time. And you can see that there is a reference connection. No, I've already mentioned about this earlier, that the reference connection. So what exactly is this reference connection? So reference connection is basically the key connection that you have in a group in checkboard. So in this instant, for group 1 of our reference connection is 374. And as you can see that this is the very first node, or that first connection that we have within this group. So what's more important about this reference connection is that this will be the main connection that you'll have to model, that you will be modeling within checkboard. And thanks to the grouping feature and this batch design that 25.0 has got. So with this, all you have to do is to model that single connection, and um, and the same connection modeling would be applied to the rest of the connections in the same group, so which saves most of your time. Now, moving further to the group description, we have the number of connections in here. As you can see, there are 8 number of connections on a total, and you can also see the typology with which we have grouped. It is either based on the number of members, the geometry, the orientation of the node, etc. But in here, according to the typology, the number of members would be 1, and we can spot it easily from here that which member or which node we have considered. The outermost uh, layer or outermost part of the frame, wherein we only have 1 member. And we also under the load have the result classes for the checks, wherein this is the new addition: calculate calculate the load extremes. Now, once you check this option, then automatically Idea Statica would analyze your critical load combinations and would only analyze for those critical load combinations. So basically, the Idea Statica would automatically group your connections, and from those you can you will be able to analyze the critical connections, and even more to shorten, we can calculate only the load extremes for those critical connections. Now, moving on with the further design processes, we are going to see the group 2, wherein we have 12 number of connections. We know how exactly the typology is, or how is this grouped. And so it goes for group 3, reference 63. So for the group 4, we have 5, and similarly we have 7 as well. You can see there are 28 number of connections. In group 8, 4 number of connections. And you can also see where exactly the group 4 is located at in this particular frame, and such that we have 13 groups, and in all those 13 groups we have 1 reference connection. And now we are going to take one connection from the group, the first group, which is the reference connection. We are opening it in Idea Statica connection application. So in here, the we have the members, we have the load effects. So most probably in the usual cases, we will have n number of load effects. It's as of now there are only 7 load effects in this particular case, but it's not necessarily the case in a real scenario. We will have more number of load effects. Now, to analyze all those load effects for all the members inside the group would be a lot of analysis. So to eliminate that, we can turn on the critical load um, check. We have viewed the connection, and now coming back to the group, in here we are checking the calculate load extremes option, which we have, and you can see that once we have clicked on the calculate load extreme option, the critical connection has dropped down to 4. Now, from 8 number of connections, 8 number of total connections, the critical connections are 4. And if you further see it, we will be able to see the critical load effects or the load combinations in each of the connection, with a max of 2 critical load combination, which simplifies, or which shortens the time of the whole design process. So it goes for group 3. We are turning on the calculate load extremes for group 3 as well. Now, from 32 connection, almost we have brought it down to 17 connections with maximum 2 critical load effects. So it goes for second group and 12 critical connections. Group 7, from 28 to in a click 20 connections with again maximum 2 critical connections, and so it goes for the entire group. Now we are going to open one connection which happened to be the critical or the reference connection as well. We have earlier seen that 374 was also marked as a critical connection. Now we are going to open the connection in Idea Statica connection application to do the to connect the members or to design the connection. Now, as we have toggled on the critical load effects, we have only 2 critical load effects that is set for the analysis. Now, the task of the designer here, that is to introduce the operations either by scratch, or you can take a proposal from Idea Statica if you have that in the connection library, such a topology in connection library, or if you have already saved that, or if you have published that particular connection. We can take it from the connection, design it, save, and then we are going back to checkboard. And you can see here that the status of the connection has slightly changed from undesigned to modeled. And by pressing calculate all, you're not just calculating 374th other reference connection, but instead you're calculating the entire connection in that group. Now, after the analysis, you will be able to see the status bar. Now it's the status is changed to analyzed, and you can see that um, the thing that you will notice here after calculating the different connections is that we have the status bar as mentioned. So here on the left hand side, for every single connection, you will see either a check mark or a cross mark, and so it goes for the next reference connection as well. We are connecting it, giving the proper spacing, and saving it. We are going back to the connection arrangement, calculating all of it, and then viewing the results. Now, while we view the results, as I was saying, we have the check, green check. We will also have blank dashes, which mean that it's a non-critical connection. So the same operations would be applied to this connection as well. Whichever is applied to the reference would be applied to to the other connection, with no further analysis. And there, if at all there was any other critical connection which wouldn't pass the code check, there would be red crows as well. Now with this, you can pretty well understand how much time it saves for a designer from grouping it manually to designing it one by one. And within seconds, we have the entire design for the connection group. And we are moving further to the next group. We are bringing in operations. So you know in Idea Statica that there is an availability of referencing 2 members at once. So this is what exactly we are doing. We are just using one operation, and simultaneously we are providing it for both. We can reinforce the operations as well. And the best part with Idea Statica 25 is that even if you are taking a parametric template from proposal, you can blend it with other operations. You can add more operations to it. There is no restriction on the number of operations as well. And furthermore, reinforcing it, and once we have reinforced it, we can save it and then back to the arrangement again. In here, we are calculating the entire connections, and we could also see the individual results the on the bottom right side. Now to generate the report, now assume that this has already been calculated. All the groups have been already calculated. Now the next task of the designer is to generate the proper report for this one. Now to generate this report, we can multi-select the reference connections, just the reference connections, and you're selecting it all for all the connections, and we are switching it to report tab. We are selecting, we are importing the selected nodes or the connections, and then we have the brief result or the table of results for the entire one. Now if you want the detailed result for the entire connections, we can click on the detail and then generate the report for that. We're generating the report for the detailed connection here for the reference connections. So in just one report, you can bring in all the connections, all the critical connections in your project. Now that is how exactly a report, bugged report, would look like. You can export it to a document or a PDF format as well, as we normally do. Now, if you have to send it as an IFC file to the modelers or detailers to communicate with them regarding the reinforcing or regarding the modeling, you can multi-select the connections. You can select all the connections at first and then export the connections to Tekla or Revit. Now here is how exactly we can do it. You need to select the connections, right click on it, and then you have an option to export. You have an option to export multiple connections as multiple files or all the connections in a single file. So for this example, we are going with all the connections in one single file. And here is how we can do it. We need to save it in, you have to save the file which contains all the connections. And then we can go to Tekla and import the saved connections to Tekla. Now, as I've already mentioned, we can import either as it as a new tab, that is as a completely new project, or you can bring it to an existing project as well. So if you have to check for the clashes, or if you have to check for the detailed changes in any of the connections, then you can superimpose the connections and then the detailers can easily check those connections. And that's how exactly uh, you can reduce the time for for the connection design for an entire project. Now to check or to explain this in detail, I'm passing the presenter on to Venki. Venki, are you there?
Yes, Rose. Okay, let me share my screen. Um, Rose, can you see my screen?
Yes, I can.
Okay, great. Thank you, Rose. And thank you, Rose, for the demonstration about the usage of the checkbot. Let's see the process in a step-by-step and some of the key aspects of the checkbot. Before going into the process, you have to integrate your global analysis model with reference to the checkbot in order to start importing your structures. So and the process of integration varies based on your respective global analysis model. So if you're not sure about the process, you can visit IDESTATICA website and go to the tutorials and browse for your respective global analysis model and check the process. Or if you're still facing issues, you can write to us at support@gsdidea.ae so that we can help you with that process. And coming back to the topic, in the screenshot shared, you can clearly see the UI of the checkbot, where in the middle, this is a structure which was imported from the respective global model, STAD in this case. So, and all the imported nodes or any structure or individual nodes will be displayed in this canvas, where you will see the entire geometry. And the first button is the connections button, which will import the selected geometry from your global analysis model into the checkbot. So the content which will be imported through this button was like the geometry and the cross section sizes along with their material grades and the load combinations. All this can be imported from this connection button. Next, we have the cubes here, which represents a node in this checkboard. So each individual node is represented by a cube, or let's call it a dynamic cube. I just called it dynamic because the as you can see, when once you imported the cube, you can see a transparent color with like white color or with brown lines. So once you have performed design operations for this node, and all you have analyzed the connection and the node connection seems to pass, then this color of this no cube tends to change to green if all the by assuming that all the code checks are passed, and the same color of the cube will change to red color if all the code checks are failed. So by this color coding of these respective cubes, with just a glance, you can identify which nodes in the structure are code check passed and which nodes are failed, and where you have to focus more. And so the next one was the tree of the connection nodes. You can see on the right side. So each cube again represents a connection node on this right, and you can clearly see the grouping process for this tree was already done, which is an automatic process. No need of any manual intervention. This automatic grouping is basically done by the number of members at each node and the orientation of the members at the node and the cross section types, whether it's an open section or closed section. Based on that types, the automatic grouping was carried out. Next was the project summary, where as Rose demonstrated the project summary, you can clearly see the number of joins or connections which were imported into the checkbot, like for in this case 118 in total, and to be designed, which means for the connections you need to apply your design operations, like maybe the parametric templates or individual operations and all that. To be checked, which is to be analyzed, and code check passed and code check failed. So this is a project summary, which you can also clearly see the status of your project, and you can confidently give your project schedules accordingly and track your project at any point of time. And next, the labels. By switching on the group labels here, you can see you can see the labels get activated for each node, which represents a group ID, group name for it, which directly means that that respective node belongs to which connection group. Like for example, in this case, there was a group named group 1. So maybe this node will be highlighted with group 1, group 2, group 2. So it's very easy to know that this respective node ID belongs to which group, which connection group, and so on. And similarly, we have the node ID and the member ID. So if you are thinking to cross-refer the checkbot model with your global analysis model, the node IDs and the member IDs in your global analysis model will be imported into the checkbot as well. So you can switch these labels for node IDs and member IDs, and you can see the same number IDs and node IDs in your global analysis model as well. And at any point of time, for instance, for any reason, your global analysis model got updated, like the cross section changed or the member size changed or the load cases changed, then you don't need to re-import the entire structure again. There is an option called sync. You can just click on the sync button. So whatever the modifications you have performed in your global model will be automatically imported into the checkbot. So you don't have to worry about the changes. This will be synchronized again automatically. And I was talking about the connection grouping, which is an automatic process. Let's see how it is done a bit in detail. So once you have imported your model or the connection model into the checkbot, even before you do anything, the checkbot will classify all the connections with logical, classify the connections and divide it into logical groups based on these two steps. So initially, the step one, it will classify all the nodes, connection nodes, based on topology, which involves number of members at the node and orientation of members at the node. Like for example, you can see in topology 1 and topology 2, where I have a column and two incoming beams. In the topology 2 as well, I have a column, there are two incoming beams, but the orientation of the column in topology 1 is a continuous column, and the same column in topology 2, it's an ended column. So there was a difference in orientation of the members, therefore it was different groups. And the same logic applies to typology 3 as well. Like there are number of incoming members is 1, so it is a different group. After segregating all the nodes which are imported into the checkboard based on this first process, which is typology grouping, then it will go to the step 2, which is cross-section types. So in the topology 1, you can see there are open sections in the first class, and in the second class, you can see the incoming members are the closed sections, and in the third type, all members at the node are closed sections. So similar logic is applicable to typology 2 and 3 as well. So based on these two criteria, the automatic grouping is performed in the checkbot, which will save a lot of time for you. If otherwise, like we have to sit with the structural drawings and go through the entire structural drawings and maybe take an Excel or a paper, and we have to group the connections manually, which is a tedious task. Checkbot helps you to auto group them automatically, which saves you a lot of time and effort. And all the groups which were grouped through checkbot are flexible. If you don't like, like if you want to modify or update any groups which were generated through checkbot, you can do that. You can remove some of the connections which were in the group and create a new group, or you can modify them as required. It is flexible, it's not rigid. And let's see some details about the critical load combinations. Once you import all the geometry from your global analysis model, all the load combinations from your global model will be imported to the checkbot. However, analyzing all the connections for all the load combinations presented in your global analysis model is time-consuming task. In addition to that, if the connection doesn't work, then the iterative process will consume more and more time, considering huge number of load cases. The time spent on this can be saved here using a simple option, which is calculate load extreme option in the checkbot. So once you switch on this option, the below details here are visible. If you don't switch on this option, you cannot see the details like the critical connection, load subgroups, and the below table. Only when you switch on, you can see these details. And let's see what are these. The critical connections are like the number of connections in that group which needs analysis. Like for example, let's say there are 15 connections in the group, and if we get critical connections as 12, then the 3 connections analysis will be skipped in this group, which are not critical, and only 12 connections will be analyzed, which needs analysis because they are critical. And the load subgroup, so checkbot found 3 distinctive sets of controlling behavior of load cases. I will talk more about this in this example about the load subgroup. So let's just remember that it's the classification of load combinations by the checkbot as a distinctive sets of load groups. And coming to the table, the first one is a load subgroup. As I just mentioned, it classified into three distinctive subgroups. The first group, and the second group, and third group. So, and the second column was the critical connection. In the load subgroup 1, the critical connection is 1, and critical load effects in that connection are 2. So what does this critical load effects means? For example, in your connection 1, if there are 6 or 7 load combinations, out of which checkbot identified there are only 2 load combinations, load effects, which are very critical. So the rest of the load combinations which are not critical will be deactivated or switched off, and only these 2 critical load effects will be active for the analysis of this critical connection, and so on. The logic is the same for all the connections which the checkbot deemed it to be a critical connection. The same logic applies. And just to see the load subgroups, let's see an example. Let's consider a connection where the topology and the cross-section type are similar and are classified in a single group. So if I take the it might be the same arrangement, but the force magnitude and direction is different, let's say. So in such a case, what checkbot does is it will list out all the similar magnitude and direction groups. It will list out all the load combinations present in those respective connections. Here you can see for the connection 1, it listed out all the load combinations presented in that particular connection, and similarly it will do for all the connections with the similar effects, and it will cluster those loads into load groups, one for each distinct controlling pattern, and picks just the critical cases for the analysis of the connection. And the same logic which was applied here will be applied here as well. So based on this logic, the load subgroups will be formed. So you can save a lot of time from this as well. Like instead of analyzing your connections for entire load combinations, and also other time we might import the forces from an Excel by filtering out the critical load effects. Uh, the the point which we miss is the connections with the similar effects we'll be analyzing twice. Like we'll analyze this ones and we'll analyze this ones. Well, this calculate load extreme algorithm accounts for that and ignores the similar effects of the load combinations and takes only the unique critical load effects and analyze the connections accordingly. In such a case, it will avoid enveloping your particular load case as well. So initially, yeah, as Jan highlighted, that you will be saving a lot of material. So if you are not designing for the envelope case, and if you're designing only for the critical respective case, then you will be obviously saving a lot of material. And here we can see the batch design. First, when you imported your entire geometry, you will model the reference connections. And like, for example, in this case, the one underlined is the major connection, the key connection or the parent connection, and all the other connections are the reference connections or child connections or dependent connections. Once you have modeled the parametric templates or operations, individual operations in this template, along with the code settings, like maybe the detailing check switched on, or maybe GMNIA switched on, or even like modal type change. Maybe you are changing from all degrees of freedom to N VZMY, which is only 3 degrees of freedom, and save your like parent connection. Then all the dependent connections or the child connections will auto import all the templates, like parametric templates or the individual operations which were already modeled, along with the code settings along with the model type changes which you have done in your parent connection to all the dependent connections or the reference connections, which will save a lot of time as well. You are analyzing individual nodes with the corresponding load cases, and hence you can perform a batch analysis as Rose demonstrated earlier for the entire group within minutes. And after analysis, the results will be saved in the checkboard itself. You don't need to open individual connection to study the results uh, of each individual node. And after you have finished your analysis of respective group, finally comes the documentation part, where you have to submit a document. So checkboard assists you to take a combined binder of selected connections. Like for example, if you want to take one connection per each group or all the connections, then you can just select the connections for which you want the report, and just select the report. In the report, there are two types of options. One is brief report and the detailed report. The brief report gives you a summary of the connections as shown in this snap. Uh, like the group ID, the respective connection, the respective highlighted connection belongs to which group, and the respective connection name and check status, along with the analysis and details. Here, details tab is empty. Only if the connection fails, then you will get a detailed statement about why it's failing. For example, plate strain exceeded 5%. That's an example. That's a failure case. In such a case, you will get a clear statement stating that if everything is okay, everything's fine, and code check is passed, then you will not see any remarks here. And that is about the brief report, which is just a summary of the selected connections. However, if you want a detailed connection, then you can press the detail option in the report, by which you will get a summary of the connections at the start, in continuation to individual report of the selected connections as well. Uh, so generally the process was like, we will open the individual connection file, take a report, and combine them as a binder. So instead of that process, if you're working from the checkboard, then you will get a combined binder for all your connections. So you can take it as a single output file, and you can attach your cover pages or detail sketches and directly submit it to the client. And that is about bulk report. So once your analysis is done and the documentation part is done, finally comes the information transfer to other departments. Like a connection designer should share the information to other departments in order for them to work. Like for example, the detail is maybe the Tekla structures or the Revit. So you can extract the information as a individual IFC files or a combined IFC file, as shown in the images right side in the Tekla structures and Revit. So the best advantage of this was, since the checkboard was imported from your global model, the checkboard also retains the exact coordinates of the nodes which was there in your global model. So once you export the IFC file, even the IFC file which was exported retains all the coordinates of the nodes which were there in your global model. So you have a 3D model in your Tekla structure which matches the coordinates of your global model. Then the IFC file which you import into Tekla structures will be superimposed exactly on the that 3D model. So you can cross check with other departments, like maybe the piping or any other departments, if there are any clashes with reference to any connections which you have designed. And also you can use it for a reference for your connection for the modelers to proceed with their activities. And so by this, I will conclude my session.
Wonderful. Thank you, Venki. That was very explanatory. So Rose displayed how the process goes. Then you followed up on each particular stage and added a bits and pieces of tips and tricks and explanations. From now on, I will take over. Please just confirm that my screen is visible. Looks like it is.
Yes, yeah.
So, thank you, Venki. So just to summarize, as I promised at the beginning, that during our webinar we will be also focusing a little bit on the time savings in detail. I want to share some of our findings that we did during the coordinated time measurements. We were actually testing how long it would actually take to go through this whole process. So let me guide you through it. In the second column, you can see time by group by minutes. So we have 1, 2, 3, 4, 5, 6, 7, 7 activities or groups of activities that we're doing. Each is taking certain portion of a time, and then we multiply it by a number of groups. For this example projects, we have 13 groups defined. So if we're importing the structure, the import just it's a data structure. It's happening on the background, though it does take time. The auto grouping and applying of all the loads, it happens in the background automatically. So it's part of the import. While the critical load checkbox here, by the time mentioning here, we mean that the calculation time of the actual load combination takes some time, and for those 13 groups it would be something around 20 minutes. Then the next step would be designing the reference connection. Again, this can hugely vary in time, and it really depends on how you approach this task. Many engineers, believe it or not, they like to begin with a blank canvas and start modeling from the scratch. While this approach works for sure, it's definitely the most time consuming one. So what we would actually recommend is to use any of the various options that you have with Idea Statica. Either use the Idea Statica wizard, or use the templates in Connection Library, or ideally use not just the regular templates, but use the parametric templates that allow you to modify just a few parameters, and then the reference connection is done even faster. So depending on how you take on the designing part, the end time actually varies. Then you follow up with the batch design by group, 32.5 minutes, and then you're off to create a beautiful report that you submit, you share with all the potential stakeholders as almost the last step, because the last step is sharing the data to the next person in line, which would be most likely detailer draftsman, who would be continuing as Venki nicely displayed. So if we total all the time for each particular activity, we're getting somewhere around 2.5 hours, which to me is very staggering, especially when we compare it to the poll that we did at the beginning, where majority of you, and by the majority I'm speaking about more than 75%, actually said that it would take more than 6 hours, at least 6 hours. This was 6 hours. More than 50% would do it 2 days or more. So really, we're speaking here about comparing Idea Statica as one of the new approaches that you can choose. Leverage the connection, detail application for the anchoring, all wrapped up in a checkbot application as a BIM workflow tool. In a few steps, you deliver the project and really save hours compared to the traditional approach. And that traditional approach can, again, it can vary. Typically, engineers use a combination of spreadsheets, simple tools, RAM connection, LimbCom, Master Series, could be Procon. All these tools are proprietary, very good at what they do. Even sometimes to this mix is included Idea Statica. A lot of engineers, they use Idea Statica for the complex. Then they use RAM connections for the everyday. They use Excel spreadsheets for the anchors. And this mix, of course, it works. But as we could see today, it's far from the most effective solution. And definitely, you're not saving yourself from the huge hassle around. So the good news is that the technology is here. The not so good news is that, and we know it, to adopt this new technology, it always takes some effort. It requires a change. So while we at GSD Idea were not able to impose or enforce the change. This unfortunately has to be done by you. We do have some of the supporting techniques, some of the supporting topics that I would like to share with you as a last thing today. But in the meantime, if you could share with us in the chat any aspect, any blocker that not allows you to change from the traditional approach to Idea Statica, we would be more than happy to know. So feel free to let us know whether it's your manager who just does not want to buy Idea Statica for you. It's your colleagues who just don't want to support you because you're not alone in the office, and everybody has to follow the same procedure. Maybe it's a price of Idea Statica. Maybe it's the time you spend on your projects and the energy you put into it, and actually not having a free day or two to look at the new approaches. So let us know. I mentioned two of the blockers that we can actually support you with. So let's look at them. If you missed our messaging on a social media or emailing, right now in the month of June, Idea Statica runs a promotion. After 3 years, so since 2023, Idea Statica used pricing that reflected the state of the application back in 2023. Now it's time that Idea Statica synchronize the pricing with the development efforts and activities that they introduced in the product in the past 3 years. So the pricing is going to go up. So in July, you can expect the price hike in the new price list. However, June is still the best time to get Idea Statica, either as a new customer. If you're not on board of Idea Statica just yet, buy a first license with a first seat. The saving you can get is 5 to 13%, depending on the type of a license and type of a licensing option that you will choose. If you are an existing customer, and you want to add more seats to your license or upgrade to the higher configuration, you can save 5 to 24%. So, as I mentioned, if the price constraint would be one of the potential issues, this is how we can support it. The second potential might be the actual adoption. We know that really getting the technology is very often not enough, and it needs sometimes the hand holding or some guidance is required. So the second very good news is that we at GSD Idea will enable our onboarding and advanced workshop platform free of charge in summer months in July and August. So our very popular onboarding training that takes 2.5 hours. It's done every week. One session is for steel, the other for concrete. Online, you can meet additional people from Ideastatica Network, and there is a Q&A section at the end. So these are available complimentary for all Ideastatica customers in June and August. And if you want to extend your knowledge in particular topics, member design, anchoring design, all the analysis types explained, you can participate on advanced workshop that also will have complimentary sessions during the summer. These are much more advanced, hands-on, so the amount of people, the count of people on each is limited to 7. So we really can go deep into the problematics, and the hands-on experience is there and can be facilitated well. So that's what you can look forward into it. So you can look forward to. So I'm running a second poll. Feel free to let us know in private if you would like to be contacted by our sales team with a specific price offer. They might reach out to you via phone or email to specify what you're looking into, and then reach out with a price offer. So if you click yes, we will do that. And while you will be voting, okay, running the poll just now. While you will be voting, I would like to share with you a few resources available on Ideastatica webpage. So the supported integrations would be the step number 1, to getting the data from your FEA model to Ideastatica. If you are not using BIMlinks, you can easily see the step-by-step guide here on the page. Just find the tool that you're using, click on it, use the step-by-step guide to get the link up and running. If you're looking into additional resources related to what you just saw today, navigate to Support Center, and of course you are free to go through any of the resources. By what we're looking here is in knowledge base articles. So here in the checkbots/BIMlinks, you can see the BIM workflows. So how to apply the critical load filter in a checkbot. This was covered today, together with all the additional topics. So you can see that everything is included, including the interface explanation, load effects, exporting to IFC. So you're not you're definitely not lost. And I'm coming back to the onboarding training and advanced workshop sessions that we will be doing during the summer. So please do check our webpage because we will be messaging you. We will be updating the dates here on the webpage, so you can directly register and take part. Good. So that's it from what we have prepared today regarding the content. Thank you very much for voting. I already see the votes for the second poll. Very happy. Thank you very much. We have been answering the questions on the go. So we're now officially ending the session, but we're staying here on the session. Feel free to keep on placing the questions, because we will be answering them as they appear. So ladies and gentlemen, thank you very much for being with us, and hope to see you at the next webinar. Thank you very much. Take care. Goodbye.